Hello, everyone. Welcome back to the Green Chemistry Education Webinar Series hosted by the Green Chemistry Commitment. My name is Amy Cannon. I'm the founder and executive director of Beyond Benign, a nonprofit organization dedicated to green chemistry education and we work in K through 12 through higher ed. This webinar series is designed to highlight relevant topics in green chemistry education for faculty and students who are looking to adopt green chemistry in their courses and programs. We are, as always, we're broadcasting live and recording the session, so all attendees are in listen-only mode and all lines are muted. So if you have a question, feel free to type it in at any time. Just type it right in there in your question or chat box on your control panel, and we'll have a look and respond to as many questions as we can after the presentation. And also, as always, we are recording, and the recordings are posted on the link that you see here and also in the chat box. And any supporting documents are also supported on these registration links, so you can also register our past. You can also access our past registration or webinars there as well. For those of you who like to participate in social media, please connect with us on Twitter or Facebook, and also feel free to do any live tweeting during the webinar. Here's a couple of our Beyond Benign Twitter handles and Facebook links here. And as always, thank you so much for joining us for this webinar and taking part in this discussion. This webinar is being brought to you as part of the Green Chemistry Commitment Program, which is a consortium program aimed at transforming chemistry education, expanding the community of green chemistry practitioners, growing resources for those looking to adopt green chemistry, improving connections, and affecting systemic change in chemistry education. So the program is a voluntary, flexible program for adopting green chemistry student learning objectives and for promoting the work that you're currently doing at your own institution to advance green chemistry. You can find more information at the link here, or feel free to also contact me directly. We are very happy to have a wonderful webinar for you today on a very important topic that's near and dear to our hearts in the green chemistry community. And it's been part of the discussion, I would say, in the green chemistry community for a while now, and that's the intersection of green chemistry and environmental justice. We're happy to have two leaders in the environmental justice community presenting in the webinar today, Monique Hardin and Martha Dina Arguello. Sorry if I mispronounced your name. We're very fortunate to have them both join in the discussion with us today and have them on the line today. So this webinar is going to be moderated by Dr. Joel Tickner. So I'm going to introduce Joel briefly and then hand things over to him to get things going with Monique and Martha. So Joel Tickner is he has wears many different hats, I would say. He is on our board here at Beyond Benign, is currently our board chair, but he's also the associate professor in the Department of Community Health and Sustainability, full professor now, right, at UMass Lowell, and he's also co-director of the Toxic Use Reduction Institute. And he also directs the Green Chemistry and Commerce Council, a network of more than 70 companies and other organizations dedicated to accelerating the adoption of green chemistry across supply chains and sectors. He has a good history in this space of green chemistry and environmental justice, having served as advisors and research for a number of different government agencies and a number of different roles. So he's a good moderator, I would say, for this discussion. So with that, I'm going to hand it over to you, Joel.
Thank you so much, Amy, and welcome everyone to the webinar. I'm just going to do a quick overview. As Amy had said, there's been a lot of discussion in the green chemistry community about environmental justice over the last few years. And my feeling was, what better way to understand environmental justice than to hear directly from community advocates working with communities that have been impacted by chemical pollution. Now, we'll learn about what environmental justice is and some of the challenges in communities, poor and minority communities around environmental justice. But for me, environmental justice was what brought me into thinking about safer chemistry. And I'll start with my mentor, Dr. Ken Geiser. He he went to Bhopal, India, about a month or two after the incident at Union Carbide that claimed several thousand lives and injured hundreds of thousands, up to hundreds of thousands, and came back and saw the devastation in a poor, primarily migrant community and said, I never want to see this again. I'm going to fight the rest of my life to never see this again. I spent several years early in my career in the 1990s in communities in Louisiana, and the meeting with community activists, working with community activists, seeing their struggles, seeing the conditions in their communities really inspired me to think about why it matters, why green chemistry matters, why what the products we're making in northern states, for example, where those raw chemicals come from, and what are the impacts on communities of those base chemicals. And I had many inspirations. The first one in the top corner was Damu Smith, who was an environmental justice leader. He worked for Greenpeace and then the Black Environmental Justice Coalition, and had a very positive vision that we wanted safe communities, we want jobs, we just don't want to be the places where all the contamination happens. And then I spent time in Convent, Louisiana, in the lower picture with Ms. Imelda West, a grandmother who had not even a high school education, but was smarter than I could ever be in my entire life, wise. We did trainings with her in the communities around cleaner production and safer chemistry. They got it. They understood that the value was really good jobs, safe manufacturing, and economic development for their communities, and communities that were as impoverished as communities I've seen in the third world. And the last person who is another inspiration for me, who I worked in several communities, is Denny Larson, who passed away 2 weeks ago, working still in Louisiana. He initiated an organization called the Bucket Brigade. You can see the bucket there. So these very simple samplers for community advocates to understand what they were being exposed to. He worked closely with another scientist in Louisiana who is a MacArthur Genius Award winner, Vilma Subra, to really help communities understand what they're exposed to and then advocate for safer solutions. So, this for me was a real inspiration for why we need green chemistry and why green chemistry matters from the community level to the disposal level and throughout the supply chain. And we have a great set of speakers for the webinar today who I think will give you a great vision of what is environmental justice and the positive implications where environmental justice and green chemistry can come together. I encourage you to keep your minds open to the discussion today, that there are challenges here, and it's important to listen to those challenges. So Monique Hardin is the Assistant Director of Law and Policy and the Community Engagement Program Manager at the Deep South Center for Environmental Justice, one of the leading environmental justice centers in the country. It's at Dillard University in New Orleans. Monique is a lawyer with more than 20 years of experience working with communities to support their struggles against pollution in their communities. Marta Arguello is the Executive Director of Physicians for Social Responsibility Los Angeles, and she has served as an advocate, community organizer, and coalition builder. And also as a coalition builder, she's been really focused on local grassroots advocacy, and she's worked at the local level, but also at the California level to instill policies that support green chemistry. In fact, she was an organizer of a workshop about 10 years ago with Dr. John Warner and other leaders in the green chemistry movement to help them think through the nexus between green chemistry, economic development, and education of future generations, particularly poor and disadvantaged community children. So with that, let me pass to Monique, and we really, really appreciate your joining us today, Monique and Martha.
Hi, thank you, Joel. Thank you, Amy. So I just need to clarify one thing. The Deep South Center for Environmental Justice, we were formerly affiliated with Dillard University, but about 2 years ago, we made the move to be an independent organization. So we're now a standalone, women-led environmental justice organization that was founded by Dr. Beverly Wright in 1992. And the work we do at Deep South Center for Environmental Justice ranges from training people for careers in environmental fields where they receive education and training, as well as certifications around how to handle mold, remediate mold, test for lead, handle asbestos, as well as do the work of remediation in and around their communities here in Louisiana. We also work regionally with a community engagement program that engages communities from in Florida, Alabama, Mississippi, Louisiana, and Texas. And we also conduct on an annual basis an HBCU climate change conference, which will be in its 7th year, will be taking place in New Orleans in November 13th through the 17th. And there's information about all of that on our website at dscej.org. So with regard to this presentation today, I must apologize that I had an unforeseen situation come up and I have to leave right after my presentation, but I understand if there are questions or ideas you might have that you'd like to discuss, what I promise to do is to be in touch with you over email, and Amy and Joel will help facilitate that communication so that we can have that at a later date. And I do apologize for this. So what I wanted to hone in on for this conversation today is, the ampersand in the title between environmental justice and green chemistry really holds a lot. One of the things that I hope it holds is how we can bridge the gap or the divide that exists between the two. In a lot of ways, I think green chemistry really holds the promise as it relates to toxic chemical manufacturing that would be, I think, analogous to what renewables are to fossil fuel industries. And so how do we get there? And how do we get there in a way that is not just driven by the technology and scientific advances, but that it really is built around a core or a principle of justice and equity? And that's extremely important, because when you see where chemical manufacturing takes place, what you will likely find is a community of color, small community, maybe off the beaten path, not heavily populated, but in that community, the residents can name and identify chemicals, and they can tell you what the health effects are. And they can tell you what their lived experience has been like with those, with the chemical manufacturing taking place. Some of them, just a stone's throw or a small one-lane street away from their front doors. And so there's a huge consideration that needs to be taken with regards to chemical and chemical manufacturing and racism. And in the United States, but it's also borne out globally, it is communities of color, people of color in the United States, where I live in Louisiana, predominantly African-American communities that have been targeted by chemical manufacturing companies and have been really used as a dumping ground with no regard for the serious health consequences and the livability of their communities. The other important facet to understand is that, right now, where there's national news coverage of this chemical facility that's being, engulfed in flames and billowing black clouds of toxic gas, smoke, that's burning itself out over the course of several days in communities in Houston, Texas, know that that same situation is possible in every community where this kind of hazardous manufacturing operations take place. And in Texas and Louisiana in particular, this is where the majority of chemical manufacturing in the United States take place, is in dotted small communities that mostly residents are Latino, African American, who are trying to live their lives like everyone else, but they have been targeted for this kind of toxic industry. But I can tell you that in Louisiana in particular, some of the slave plantations that once existed have been taken over by industrial companies, some of which continue to use the name of the old slave plantations. And with regards to poverty, I think it's also maybe an important perspective to think about to share with you something that I learned in this early on in this work as an attorney and an advocate for environmental justice, which is an elder who told me that when she was growing up in a historic African American community that now became surrounded by 14 toxic industrial facilities over the decades, that she didn't know she was poor, and that was because her community was able to live very well with the rich biodiversity. They could farm, they could hunt, they could fish, they could share with other community members and live very well. They didn't necessarily need to derive their wealth from an income because they could live virtually off the land and create small businesses as a result. That all changed with the introduction of industrial facilities that made from fish kills, the water's so toxic that it's even warned against swimming, to unhealthy levels of cancer-causing chemicals in the air. This is the consequence of toxic chemical manufacturing that green chemistry holds some hope for doing in a very different way that it needs to be humane. And at the bottom of every demand for environmental justice is a demand for human rights. And when we look at the situation of chemical manufacturing and race, what you're seeing are two photographs. The thing to hone in on is the year that the photos were taken and where they were taken. So even though the children are growing up in community playgrounds that are right next to chemical manufacturing facilities, they're separated by an ocean, they're separated by language, they're separated by different cultures, but they have the same almost identical environmental condition. And it's one where it's not helped by environmental laws. The photograph you see of the Diamond community is some 30 years after the Clean Air Act was enacted, and the Clean Water Act soon after that. The photograph from Durban, South Africa was taken at a time when there were no national environmental laws on environmental protection. And so so when we talk about the U.S. and where our environmental laws are, how is it that these two photographs are both possible? And so we're going to delve into that a little bit more, because I think there's often kind of a misperception about what our environmental laws do and how protective they are. And as the photographs show, that you can have the situation in the community of Diamond, in a town called Norco, Louisiana, is the same as those of children where there are no such Clean Air Act or Clean Water Act that are ostensibly there to protect them. By the way, Norco is actually an acronym for New Orleans Refining Company, and it was the name of the company that began in 1930s in Louisiana and was later taken over by Royal Dutch Shell. The facility you see in the background it's now under a different ownership, but it was a chemical manufacturing arm of the Shell oil complex that is established there in the Norco town. Next slide, please. So how does it begin? Well, you'll see a very skinny column in your local newspaper and the legal notices that will have something that looks like this. This is kind of an excerpted public notice, an example from the state of Louisiana, our Department of Environmental Quality, notifying the readers and the public of a proposed permit for air pollution by a particular chemical company. And at the bottom, you have the estimated air emissions of certain chemicals and tons per year. And in this case, it's a air permit that's sought not for new construction, but for an existing facility, and with some modifications being made. So it's actually a permit renewal. And what happens is that with these permits, if they're some of them, there's an every 5-year renewal or update, and so that's an opportunity where people can weigh in through a public comment process as to whether or not this permit should be issued. What typically happens is that finding this kind of information is really hard to come by. It can appear in the legal notice, 6-point type, and completely be just kind of under radar for members in the community. And then it's not until later that they find out that a permit has been issued and there's construction for maybe a new unit that's being tacked on to an existing facility that would increase pollution levels above where they were previously allowed. And so you can have a situation very easily where a community just is completely left out or excluded from having any say in what goes on. And in other cases, you can have a community that gets very organized, learns about how the process works around permitting, and tries to engage. And there, the results can be virtually the same as though they had not ever commented. And I want to explain why. And that's the next slide. So this is an example of how permits get issued, looking at the laws that govern what's required for a permit. So we're looking at, in this case, an air permit. Under U.S. environmental laws, a facility cannot build or expand without requisite permits mandated by the Clean Air Act. And so, therefore, the Clean Air Act is extremely important in terms of the yay or nay on whether an industrial company is able to build a facility or to add new units to a facility. So what do they have to do? They have to meet the requirements of the law. So what are the requirements? I have it very short shrift, and this is the essence of how it boils down. The permit standards are based on industrial sector operations, and it really boils down to just codifying into law existing industrial operations. And so, for example, if you are an industrial company in the United States, or you could be a foreign company as well, but planning to build in the United States, and your industrial sector within the United States has 30 or more facilities owned by a variety of other companies. Well, in that case, under the law, the permitting standards would be developed and promulgated by the Environmental Protection Agency based on what the 12% of the lowest emitters within your industrial sector entails. And so the illustration shows you 30 industrial smokestacks. Hold on, my computer just went to hibernation mode. Just give me 1 minute, I'm sorry. Can you all still see the screen?
Yes.
Okay. All right, I'll just follow on paper. I don't know what just happened there. So you have an industrial sector with 30 facilities as shown in the illustration. And the rule under the Clean Air Act is that 12% of those facilities that happen to have the lowest emission, they basically dictate the standards of the permit. And so you see 4 outlined. So, 12% out of 30 is roughly 4 facilities. What EPA does is it sends out a questionnaire or a survey to each of the industrial facilities about their operations and their calculated emission of various pollutants, and they get back information. Sometimes all the information isn't filled in because the businesses claim some proprietary interest or trade secret or something to the like. But whatever the information that EPA is able to cobble together, they then look at. They then identify those that are among the lowest of the emitters, and then they look at what are those operation details and emission details, and they cobble together permitting standards based on that information. For an industrial sector that has less than 30 factories owned by various companies in the United States, you just go by a fixed number of the 5 lowest emitters. So what does that mean? It means that if you have a concern about the health effects of this pollution, the effects that it might have on your property values, what it might mean for your general quality of life, what could happen in the event of an accident, should it be as close to your home or the school you attended by your children, all of those concerns are kind of left to the side, because the only thing that the industry has to do to get a permit under the law is basically meet the standard as established, premised on the operations of, in this case, the 4 factories that are then turned into requirements for the permit. So in that way, the result can be just the same as if a community comes to a public hearing based on that public notice in the previous slide, and they complain about maybe cancers being a concern or reproductive damage that's linked and scientifically known to be an effect of one or more of the pollutants that would be proposed for a permit, an air permit. Those concerns, and which are very real, right? And they're talking about their survival, have no moment for the agencies that write the permits. And what will typically come back is a response that says the applicant, company X or Y seeking the permit, meets the requirements of the Clean Air Act law and regulations, and is therefore presumptively protective of human health and the environment. And so the permit is issued. The facility can begin building, it can begin releasing pollution into the community based on the presumption that it's protective, but the communities have to live with the reality that it's not. Next slide. So what does that look like? It looks like the Exxon chemical and oil complex that's right outside of the state capitol in Baton Rouge, Louisiana, which had a major accident some Christmases ago. That was a major disaster. What you don't see in this photograph is the tiny historic African-American community of Alson, where Exxon is right next door to where people live. But this is legal under our Clean Air Act, because proximity to residential areas, proximity to schools, proximity to places of worship, playgrounds, and the like are not part of any requirement for getting a permit. Next slide. And so this is what it looks like at night. And so many people in communities that are fence line often don't sleep in pajamas or nightgowns or something maybe more risque, but they sleep some in regular street clothes in the event that they need to evacuate their homes in the middle of the night. And it's typically in the middle of the night that the facilities are at their worst, where the flares are, where it looks like this photograph, where the flares are very high, the flames, you can see them through your window, the noises are louder, booming operations, and the odors are unbearable. Next slide. And even in the daytime, it doesn't really matter. This is a community in Port Arthur, Texas, with the Valero oil refinery in the background, flaring out of control. Next. This is a community resident who, in Mossville, Louisiana, who erected these signs for a house for sale. It's a bit tongue-in-cheek, but it's also kind of expressing their frustration of contamination by a vinyl chloride manufacturing facility that operated right across the street. In fact, where the facility is located, if you were to stand on the facility grounds, you would be looking at the signs. The sign faced the facility. Next slide. And this is a sign that was also erected by people in Mossville for workers and family members who died from diseases and medical conditions linked to toxic exposure. It reads in memory of workers and citizens who have paid with their lives for a toxic environment. Our fight for a clean environment is for you, our families, and our future. And written there are the names of the people who passed on. Next slide. And here is another community called Morrisonville. It no longer exists. In fact, I should say that the community in Diamond that you saw in that earlier photograph of the two boys in the playground, the community of Mossville, where you saw the house for sale sign, and this community of Morrisonville have been relocated as a result of toxic pollution and concerns, and the community being able to fight for their relocation away from the toxic conditions created by the chemical companies. And these were very hard-fought struggles for the Diamond community. It took them over 17 years. For Mossville, their fight for relocation was an opportune moment for a company that was landlocked and could only expand into the area of Mossville, and so therefore began ponying up the cost of relocating residents. And here is Morrisonville, where you see the storage tank and the smokestacks of Dow Chemical. And what's left of Morrisonville is a cemetery that for relatives who want to visit have to go through the Dow security guard shack area in order to have access and entry to the cemetery that was once was part of their historic African American communities before Dow Chemical took it over. Their relocation was premised on Dow's concern at a time when the Clean Air Act was going through an amendment as to whether or not the residents might be successful in a lawsuit after it was scientifically discovered through some body burden blood tests that were voluntarily done by some of the residents that there were high levels of vinyl chloride in their bloodstream, a potent human carcinogen that's used in the making of vinyl plastics. Next slide. And so with this kind of chemical manufacturing, the gift just keeps on giving, because it brings us with climate change, because much of the chemicals that are manufactured often include ethylene and other oil wastes. And so there's this kind of back and forth of swapping of chemicals and materials between an oil company, oil refining operation, and a petrochemical facility like vinyl, which uses quite a bit of ethylene in the making of vinyl, for example, but also the Shell Chemical also used ethylene in their plastics manufacturing process that was in the Diamond community of Norco. But so it also contributes to the climate change effect with greenhouse gas emissions. And there's, tremendous racial component to all of that, because not only do you have people of color on the fence line where the stuff is made in the first place, but you also have, I think this is an animation. Can you click? You also have the warming of our planet, and this is a satellite photo map of Hurricane Katrina as it was entering the Gulf of Mexico in 2005, and it shows you the higher temperatures of water around you can see the eye of the storm and the swirl there of the hurricane, and you can see where it's reddest right along the coast, right underneath the bottom of Louisiana. I hope y'all can see that pretty clearly on your screens. And then, of course, on the effects of that climate change are rising waters and stronger hurricanes, and of course drought and other extreme weather, wildfires, tornadoes, and the people who are affected the first and the worst are, again, people of color. And this is a photograph from New Orleans after Hurricane Katrina with folks on a rooftop looking for help and rescue from a city that was about 80% underwater. Next slide. So I have 3 questions, and I know you all have questions, and I'm going to have to leave, so I hope we can continue the conversation over email, but these are just 3 questions I wanted to leave you with. One is, how can green chemistry contribute to achieving environmental justice and climate justice? What would that really look like, and what would that work look like? And this is really trying to bring it out of an academic field, but one that can make a difference in the lives of so many people. 2, what are the opportunities for green chemists and students of green chemistry to work in solidarity with communities of color who are disproportionately exposed to toxic chemicals and vulnerable to climate change? And last, are there racial justice principles that are internal to green chemistry? Like, why do you study it? Why do you teach it? Is there a sense of ways in which society can be improved or transformed in a way that brings more of egalitarian, equitable treatment of all people? And so that's it for me. I'm going to have to run now, but I hope this was helpful, and I would love to continue the conversation with you all. Thanks, Joel, Amy. Take it away, Martha.
Great. Thank you so much, Monique. And I think this nexus is as Amy switches the slides, this connection between environmental justice, climate justice, between green chemistry, climate change, and climate impacts. We saw this after Katrina. We saw it after Harvey, and some of the contamination, which primarily occurred in minority and poor neighborhoods after Hurricane Harvey. So with that, let's transition to efforts in Los Angeles and Martha.
Good afternoon. Well, actually morning here in LA. So I want to really emphasize the questions that Monique left us with, because those are the questions that have been central to a lot of the work that we have been doing in a number of communities. And I'm going to give a lot of these examples are from our work in South Los Angeles, where we are working with a range of social justice organizations on addressing historic health disparities, inequalities, so everything from the school to prison pipeline to the issues of the legacy of land and soil and water contamination. And so we talk about restoring this South Los Angeles from the soil to the soul, acknowledging that the experience of systematic discrimination based on race and ethnicity, or particularly in South Los Angeles, that has one of the largest indigenous communities, both from Latin America, but also from native to this country. South Los Angeles is on Tongva land that was taken from the Tongva. So that has left both sort of a physical scar as well as in many ways a psychic one. So next slide. And so we've been asking, how do we solve these problems by using green chemistry? And this is just a poster that talks about this work we're all doing about transforming our communities from the soil to the soul. Next slide. And the work that Joel talked about is that we've been concerned with this for a long time. As a physicians organization that is run by a woman of color for the last 10 years and has been really working in close relationship with communities who are impacted by sort of what we call the sins of the past, right? The fact that we cite these facilities in low-income communities. We have poor nobody's minding the store, and we don't have a good way to clean them up. And at the same time, while we did a lot of work on climate, we also did a lot of work on toxics. And we just felt that the conversation about the new green economy was leaving out the materials economy and leaving out small business, and was, at that point in 2011 was all about solar panels. So we started really thinking, because we were really inspired by the work of green chemistry, and California had done a number of attempts to figure out what's a technology forcing policy to promote green chemistry solutions. And there's a separate webinar we could evaluate how well or not well that experiment went in California, but we were really clear from that is that we needed to do more to link green chemistry to environmental justice. Next slide. So what we have been doing as an environmental justice community and a public health community is saying, well, what does it look like, right? What does our current system look like in ways that folks can understand? So a number of years of advocacy created what is called the CalEnviroscreen, which takes 19 measures of community vulnerability, including impaired water bodies, air pollution. Not a lot of health endpoints because we don't do a good job of collecting health data, but we've got cancer risk and I believe reproductive risk and maybe asthma in here. I'm not sure, remembering all the 19 measures off the top of my head, but this is Los Angeles. This is where I grew up. So the darker the red, the more pollution. So this has allowed the state of California to rank communities by level of pollution. So this is where we work. So this is South and Southeast Los Angeles, where, you know, not surprising, we did a lot of production, right? A lot of military production, a lot of industrial production. We had auto, you know, the auto industry was here. Next slide. So this is a little bit of a blowout of that one, so where you could actually see the names of the cities. So you've got the Southeast cities, Huntington Park, Bell Gardens, Southgate, Vernon, where there's a, you know, Vernon pollutes the entire area because it's a little area, loose regulatory structure, only 200 residents, but a lot of industrial production, and it is responsible for sending out a lot of emissions, including, you know, battery recycling, and there's a lot of lead still being emitted throughout the south and southeast areas of Los Angeles. Next slide. And this is a mapping we've done of metal manufacturers, where they are situated, because we, and I'll talk a little bit why we looked at this particular industry. So we've got quite a bit of these manufacturers, and this is lead, cadmium, and other heavy metals that are being released. Next slide. But it's important for us to understand where are the industries and where are the emissions coming from. And then the last thing, my last picture did not show up on there, but this is what LA used to look like. That's a beach of what the beach is now. There it is. That's what our beaches used to look like. And that picture there in the center, that's actually not, you know, about 2 miles from where I live now, which is in the Silver Lake area. So the Echo Park, Silver Lake parts of Los Angeles used to be oil extraction. Next slide. And that extraction has moved to, guess where? Well, it was always there, but it got moved from the beaches and then got pushed into the South LA, where we have, you know, we had racially restricted covenants about who could buy property. So you've got this proximity of extraction of oil next to primarily African American and Latino communities, deeply embedded in urban communities, highly densely populated. Next slide. So we live this sort of spider web of petrochemicals and both extraction and production, because we have some large base chemical production, pesticide manufacturers that are buying expired patents. This, you know, the range of bad behavior you can imagine that Monique talked about also happens in Los Angeles. So we've approached this from a number of regulatory angles, and I think that without green chemistry, all our angles they're not complete, right? We have this justice gap in how regulatory functions, regulatory agencies work. So we have a justice gap and a health gap and a human rights gap, right? Because communities are being, what folks in, you see the picture here, these folks are actually playing a land use game, where you actually have to decide, well, where are you going to place things? Where would you put the school? Where would you put the recycling facility? Where would you put this, right? So they get to live in a way how difficult those decisions are. Next slide. But we also did this to collect data, because there's a lot of sources that aren't documented because no one is minding the store. So this is an online tool you can go and it will tell you how far you are from a facility. It was designed as a land use tool. But what it has shown us is that there is a bunch of small industries that cumulatively are affecting communities, and our own people also work in those communities. So we have to figure out an upstream solution that's, you know, brings in concepts of clean production, biomimicry. Our neighborhoods desperately need to fill not only the justice gap, but that kind of innovation gap. Next slide. So that 500 tool has helped us identify many of the hidden dangers that are in Los Angeles. These are just some of the wells. So the one with the pretty colors and covered up, all that, that's not surprisingly Beverly Hills. The other ones that just are not covered up, where you've got the shrubbery, are more what they look like in the South neighborhoods. But next slide. So these are like next to where people live. These are some of the, this is how our communities experience chemistry. These are actually housed on site next to where people live. And we're often have, we manage to get a picture, we manage to blow it up. That's how we know these chemicals are being stored. This is a photo taken by a community advocate, not given to us by government. And then we had, next slide, then we had to, there was bills. This is actually a bill that was passed to let us know what chemicals are being used in urban drilling. But we also understand, next slide, that it's not just about drilling, that it's the materials economy, it's heavy metals. And so, again, as much as folks talk about regulation in California, this is still happening in communities, and we are not deploying alternatives even when we have them. Next slide. And then the biggest issue is that we're not asking the right questions. So yes, the questions that Monique was asking, but also, we were working with an elementary school, and their way of teaching science was, what are the problems that science could help you? You can use the tools of science to solve problems in your community. And so the 500-foot tool, the data collection, the air monitoring, all these tools that we've been developing to give to communities are just one part of it, right? The next thing we're doing is we're actually now starting to work with UCLA, but we want a lot more partnerships in this sort of problem-based solutions. Next slide. So this is a scary little word cloud of how my mind works, and how all of the things that we sort of have to address, right? I've talked about the need to have cradle-to-cradle thinking, but also ask, how does justice fit in there? And it has to be a central part of it. What are the principles of justice that we can embed in the principles of green chemistry? How do we talk about a just transition? How are we going to be training the next generation of people who can do alternatives assessment, who can do life cycle analysis, who can do, ask those critical questions? Is it necessary? We know that we've been working on green zones, but without the green chemistry tools, we can't create these healthy green zones. But we also face the reality that as we clean up communities, as we bring amenities, as we eliminate toxic hazards, we now have to deal with this issue of green gentrification and displacement. So the issue of, if you don't embed justice, even at the level of molecules, then we continue to recreate and embed and reify the inequality that already exists. Next slide. So, here are some of the places that we're actually seeking some green chemistry solutions, right? So because they're also engines of economic development for low-income communities, and they're really toxic. So nail salons, cleaning products for domestic workers, auto body shops. We've been working with the garment cleaning industry and innovators within that industry, and California is sort of a poster child for, you've got a perfectly safer alternative, but the petrochemical industry kind of killed it, and we've not been able to. Now, wet cleaning is not what's on the market, and that's where we need to shift. So the work that we're doing with Physicians for Social Responsibility and Californians for a Healthy and Green Economy is asking this central question: how does the green chemistry program of California become more linked to this issue of how we deal with our hazardous waste? How do we deal with cleanup issues so that the green chemistry program isn't just working as a thing about creating consumer products? So we're sort of in the process of figuring out what that might look like, and having broadening the set of conversations with more of our partners within the toxics movement. Next slide. And then locally, this is really exciting, and that's why the slide is not finished, because I don't know what to tell you. There is a city council vote happening right now. We have been working with a broad coalition of frontline groups and technical advisors on this idea of how do we democratize, decarbonize, and detoxify Los Angeles and get to those goals by 2025. And we have this concept of the green sword that is really the toxics piece, right? How do we detoxify our economy? How do we look at this industrial shell that's throughout Southeast LA and the manufacturing shell that is all moved away as we've moved to China? Can that be revitalized? And can we bring principles of green chemistry and clean production to that and revitalize that, right? And then the second part is, how do we embed the idea of this detoxify, decarbonize into conversations about climate justice? And the vote that's taking place is, can we create a climate justice emergency department within the city of LA that would take on this dual question of, addressing the issues from the materials economy standpoint, as well as from a carbon standpoint. And you know who's missing at our table right now? Scientists who actually can tell us, where we can actually share in some, what I call, revolutionary imagination of what's possible. And to answer that question, can we imbue molecules with the concept of justice? So thank you.
That's wonderful. If I could just, before I give Joel, I was really inspired by your statement of embed justice in molecules. It really gets to the heart of what green chemistry is about. It's all about really designing chemistry in a way that we don't have to mitigate or worry about hazards and pollution after the fact. That we have tremendous power as molecular designers to do it right first place. So I love that, and I can see bumper stickers and taglines coming. So. So Joel, I'm going to hand that over to you to get us started
Great.
with the discussion. Yeah, go ahead.
Yeah, and Amy, you have access to the questions, but let me start, Martha, with a question about sort of how the green chemistry community, so professors, you have professors on the phone, students on the phone, how do they get better connected to communities and environmental justice advocates to understand what their needs and challenges are and how chemistry can be part of the solution?
Well, we thought about that, right? So we thought we want to do a set of exchanges and tours so that folks could see what it's like. We've taken regulators on tours and they always gasp and it frightens me. I'm like, you're the regulator, you should know what's happening on the ground. So I think that part, I was so inspired by John Warner saying, I'm a green chemist. I can go into that pesticide manufacturer and say, so what are your inputs, right? In a way that you as an advocate can't, right? Because they see me and they're like, she's going to try to close us down. And so we want to work differently. So I think, us talking more, having more of a chance to do face-to-face and just sort of what we in our work call sort of the curiosity interviews before you start thinking about what you're going to do. Because I don't know that we even have a shared language sometimes between scientists and environmental justice communities.
Great. And is there a way to build that language? So I think one of the considerations we had seen in some of the green chemistry discussions about environmental justice was about justice in terms of access to education, but not necessarily justice in terms of communities affected by pollution. And, how do you see that evolving, that conversation?
Well, my background is in popular education, so I do imagine this this idea of a problem-solving team, right? And that would, so for example, the issue of cleaning products, right, and domestic workers, and if they were to make a safe product, well, what's the missing thing to be able to make that product? What's preservatives, right? So how do we sit down and say, here's the toxic trio in nail polish. What's a green chemistry solution? What's an upstream solution? Is there a change in the manufacturing process? That kind of exchange is one way. The other thing that we've been exploring, and I would love, I guess I would love to sort of follow this up with maybe a face-to-face meeting with some scientists, is how do we incorporate scientists into community decision-making, right? Because risk assessment is the thing that's gotten us here. And this idea, the democratized piece is, how do we give communities the right to decide? And most of the time, we will balance, jobs versus the environment in a very different way. But we admit that it has to be balanced, right? So an alternatives assessment, we're trying to figure out that too, right? How do we build in that kind of democratization to decision making so that we're driving innovation through policy change as well? Oh, that was rambling. Sorry.
Great. And then, let me ask a follow-up on, I know you've been trying to think about how to engage educational K through 12 and university education. And Beyond Benign, its focus is on green chemistry, STEM education, and an increasing interest in disadvantaged communities in education. So do you have thoughts and strategies of how we create the next generation of community-based scientists or who come from communities, affected communities, who really understand the challenges, but then can design the solutions?
Yes, I think at the community college level and the trade, this idea that also, that John Warner also sort of planted the seed is, who is going to train the next generation of folks working in the labs? So that part, I think, is important. I think in terms of early education, I think of one of, a friend of mine's daughter developed an app for farm workers to use around heat, right? So this idea of gamification, how do we gamify this concept of documenting and finding solutions to community, pollution problems, right? So that's one approach. And then the other, the idea of partnering with community organizations is that there are, East Yard Communities for Environmental Justice, for example, has a research institute. A lot of it's been focused on the social sciences, which are really critical. But what would, that partnership look like with someone who's getting a PhD in green chemistry, right? What would they bring to the table when they're talking about, there's battery recycling facilities, there's a pesticide manufacturing facility, there's, the impacts of global trade. And I don't think so I don't know what the spaces are. I would actually ask maybe folks on the phone, what are the spaces that we should be talking to, to make that dialogue happen.
And if you do have a question, remember you can put that in the Q&A box on your display panel. And Amy, you had a question.
Yeah, we had a few coming in about some of the resources. One of them that you mentioned is the land use app. I think it's the one that you mentioned, the 500 feet away. Is that available online and where? So that maybe that's
yes.
So yeah,
you do.
Okay.
PSRLA 500-foot tool. We're finalizing the report. We're adding more census tracts. And we're open to, we're going to be adding air quality data to those layers. So
great.
We would love,
I think what we might do from this, because we also have a question about can you post those 3 questions that Monique had in her slide too. So maybe what we'll do is put together sort of a resource list based on your 2 presentations. We also had a question because, as Joel mentioned, we have a lot of educators on the line, so I think this one comes from that. Do you have case studies, either local, regional, national, which it sounds like you guys have mentioned several sort of throughout your presentations, but do you have case studies to share to help us consider how to best address these questions and to get students thinking about these challenges early? So I guess they're looking for concrete case studies to share in their courses.
I would take the molecules to movements, public health and green jobs. We took a case study approach there. I don't
Okay.
know how, but I don't know how useful they would be. So I mean, that might be a starting point.
Yeah, and I would add in that there are a lot of folks in the environmental justice community who've written case studies. The Deep South Center, Dr. Robert Bullard Center has written some. Phil Brown and Danny Faber at Northeastern University have written a lot of case studies on environmental justice struggles. So there is a lot of literature out there, both from the sociological side as well as the scientific side, that and EPA does have an environmental justice program. So there's a lot of literature out there, and we could pull together some case examples where communities have struggled and where solutions might be to some of those struggles. And certainly a lot has been written up, I think, Martha, about the Latino cleaning workers and some of their efforts. And actually in California, there's been a lot of work on nail salon workers and looking at green chemistry solutions in that group as well. So when we talk about environmental justice, it's not just at the community level, it's also, minority and poor workers in conditions where they're exposed to disproportionate amounts of toxic exposure compared to white affluent people.
And we have another question about how much do the EJ communities reach out to chemists or scientists at the companies in the communities, and how has that dialogue gone, if so? So I guess looking for, mentioned some specific companies were mentioned in this, and maybe, how was that, has that been productive, or those conversations? Yeah.
Martha, maybe you could weigh in on that one.
I'm sorry, there was a little background noise here.
Well,
I didn't quite hear.
Yeah, I think the question is, to what degree have you engaged with actual facilities to have conversations about community concerns, and how what kinds of experiences have those resulted in?
Sure. So over the years, some have not gone well. And so I know there was at one point an effort, not by us, but by one of our allies, to work with auto body shops. And we learned a lot there. And we're trying to figure out ways to fund a new approach. But the one that's been really exciting has been with the metal. Again, it's the metals industry, because we passed a bill, that said what the lead level had to be in municipal water systems, and there wasn't a technology to meet it. So we spent, we've done a full life cycle assessment of it, and it's a facility that's in South LA, and they sort of made commitments to reduce effluent. It requires less mining, so it's a really, and if we could deploy the EcoBrass, it's actually a job creator. So that's one that's kind of exciting to us. And I would, part of our learning we want to do is to learn more from the green chemist. Where are other stories like this? And then there's the wet cleaning, which is not green chemistry. It's just a process, right? That doesn't require chemicals. And that we haven't been also, so we've learned a lot of what the barriers are to getting good alternatives to market. I'll put it that way.
That's great. I think we are at the close here. Joel, if you want to wrap up.
Yeah, I thank everyone for being on the call today. I think there are great opportunities, as I've said, spending time with in communities and with people like Monique and Martha has given me a much broader and important perspective on the impact of the work I do and why I do it. As Monique had said, communities who face shelter-in-place advisories on a regular basis, communities that really want economic development. They want jobs, they want good jobs, and they want a healthy, clean environment and clean workplaces, something all of us aspire to have. So there's a great opportunity for green chemistry to support these community activities and help find the win-win solutions that are, good for your economy and good for communities and the environment. And really, I think, Martha, you had such a nice statement there about putting a justice lens to chemistry, and I think building that into why chemistry matters and why we do what we do. It's not just to make the next molecule, but it's to make the world better. So with that, I want to thank Martha and Monique for spending time with us today, and hopefully this stimulates some discussion in the green chemistry community. So Amy, yours to close.
Wonderful. Thank you all so much. Thank you, Joel, Martha, and Monique. It's been a wonderful, wonderful discussion, and hopefully it's the beginning to many more. We've already got some comments in that of green chemists wanting to help. So thank you so much.
Thank you.
Thank you.